Okay. Guys, if you decide you don't need a review, I don't need one. So let me ask you, do you want a review or no?
I do.
Yeah, I don't.
All right, then let's pull this together.
Well, I want to review, but I want to do it on my own.
Go ahead. Just don't disrupt it when I'm doing this. All right. You have 2 units we have. 5.4 and 5.5. This is both on your test. I like to put these together because they have nothing in common. 5.4 says you're talking about a population, you're using your z-score, however, you're given a sample. So n is equal to something. So your mean, you said, stays the same. The mean for your sample will be the mean from your population, but your standard deviation is going to change based on that n. And that's the guy that we're putting in your z-score. Basically, that's what 5.4 says. And I always set the test up, don't mix up the questions. So I'll go through like 5.4 questions, and then I'll show you where to look for that's going to change to 5.5. 5.5, Dylan, if you could grab one in the middle of that table when you come through. 5.5 deals with the binomial situation. So the first thing we had to do was check to make sure that it approximates a normal distribution. Okay, when we did this one, n had to be greater than or equal to 30, or they had to tell us it approximated a normal distribution. Once you do this, you're going to realize you have no mean, you have no standard deviation, you have to use these formulas. Okay, once you do that, you can use your regular z-score formula after it's correct for continuity. Remember to do this in here. In other words, your numbers are discrete in your binomial. Your bars on your graph are not. They need to have area. So we're going to correct, and we'll review the correction again. So they basically work the same, but they're totally different approaches. So I don't think you should have a problem with that. So if we look at this one, it says the annual per capita consumption of citrus fruit by people in the United States is normally distributed. They're telling us it's normally distributed with a mean. Is this my population or my sample?
Population.
Good. It's talking about the whole United States and a standard deviation of 20.5 pounds. So this is your population information. 20.5? Okay, now, random samples of 35 are drawn. What is that? N. That's my N. Find the mean and the standard error of the mean. What does that mean to me? So the mean from my sample is what? The same. But my standard deviation changes how?
Standard deviation divided by the square root of the sample.
Good. This is what's forcing me to change. That n has to be somewhere. I got to use it somewhere. That's the only place I'm going to care about it, is changing it to over my standard deviation. If it gives you a piece of information other than like this age group is from 60 to 62 and this weight is from 49 pounds to 52, if it gives you a part of the description, that's not important. But if it gives you a piece of information like the sample size, you got to use it. So this tells me, okay, my mean stays the same, but my standard deviation will change.
To 3.47.
Okay, so now if you want to round to the same as your mean. So just round to whatever your mean is, do the same rounding. Your sketch comes from this guy. So when you sketch, your mean goes in the middle and then you'll add 3.5 all the way up. So you'll get 89.1, and you'll keep on going. Don't use 20.5. Use your new standard deviation. That's what I mean by a sketch. So it'll go 92.6 and 96.1, and then it'll go down by 3.5. 82.1, 78.6, and 75.1, as long as you use your new standard deviation. Basically, this is 5.4. Everything else will work the same. If you go to setup and you didn't have to do any z-scores, I didn't ask you any probability statements. But any z-scores go off this information. So that's the crux of 5.4. You're changing your standard deviation for your sample. Okay? And we'll go over the ones that you have there, but we'll do one of these first. Since these we did like the furthest away, we just did the 5.5. With the sample, that's the standard error of the mean. Because what happens is when you do samples, you're not always sure, is this a good representation of your population? Especially only having 35 in there, it's not a very large sample to represent a population. So if you get 35 that are way off your mean, you need to have like something to help you define that closer, which is why we divide that. So they call it a sampling error of the mean.
So just leave it like that?
That's all that question asked for. Now we're going to build on this. So, do this one with me, guys. This is typical of what you're going to see. The mean value of the land and the buildings per acre for all the farms in Illinois, so I'm dealing with my population, is $6,700. This is my population for the farms in Illinois. A random sample of 36 is drawn. Assume the population standard deviation population is 1250. So what is the first thing I should do?
Change your standard deviation.
Good. Change my standard deviation. Happens to me all the time here. Okay, divide this by the square root of 36, which is 6. So this should divide, and you should get a standard deviation of 208.3. Now, rule of thumb, go one more decimal than your data. So if my mean is that, I can round it to my mean. I can go one more decimal. When you make your sketch, round it. Your sketch doesn't have to be as exact. Here's my sketch. My mean goes in the middle.
Round it to 208.
Now round it to 208. Just keep adding 208. My sketch doesn't have to be on spot. It has to tell me, I use a sketch to say, am I greater than 50%, am I less than 50%? It helps me see where my shading is. So just keep adding 208. So 6908, 7116, 7324. My sketch has to be from this guy. It took my standard deviation and it shrunk it in. So my original sketch with my 1250 looks like this. My one that I'm doing is going to look like this. So I certainly don't want to put 211. And then just go down the other way. 62, 84, you're just subtracting, and 6,076. Basic sketch. So, that's my information. That's how we start. And now you're going to deal with your probabilities. What is the probability that the mean value of the land is less than 7,200? How do I write that probability statement? Okay, that's all I need to do. So now I look for 7,200. 7,200's over here somewhere. If it's less, this is why we shade. Should my area be more than 50% or less than 50%? More than. And I always look up area to the left, so this should work for me. So I use my z-score formula. If you want to replace this with 208.3, you can replace it with 208.3. If you want to let your calculator do it, let your calculator do it. In other words, if you want to do this, 1250 divided by the square root of 36, or you want to put in the actual 208.3, either one is fine with me. If you're going to let your calculator do it, again, you can bypass that by doing it in your calculator. Go to the normal distribution. Cumulative area is from the left on up. My lower limit is negative 999. My upper limit is my x value, 7,200, does it say? That's my upper limit. Change these guys. And watch. Let your calculator do this. 1250 divided by the square root of 36. Let your calculator do it. And paste. Oops. Paste. Okay, that gives you your area. So if I found my z-score and I looked at my area, that's my answer. If I'm using my equation, I find my z-score and I say my z-score is 1.44. Oops, sorry, I'm in the wrong one.
It's actually 2.4.
It's actually 2.4, sorry. 2.4. My z-score is 2.4. If I look up in my table, I'm actually 9918. Same that I found on my calc. The only thing I want you to do, if you use your calculator, is to show me your steps. And again, it's for your safety, not mine, as well, because if you forget to put your standard deviation in with the square root of 36, divided by the square root of 36, I don't see it. Your total answer is completely wrong, and you get no credit because you're not going to show me any of this work. You're just going to give me your answer. If I saw that your standard deviation was not divided by the square root of 36, I would at least know you still did your lower limit, you still did your upper limit, and I'll put it in my calculator to get what you get. And you lose partial credit, not the whole thing. So be careful on that. Okay. If you want to leave it as a decimal, that's fine. If you want to move it to a percent, that's fine too. Okay? Let's try another one. What is the probability that it's more than 6,500? How do I say that? Good. That's all I have to do. I find my 6,500 and I shade. You can just do this once and shade. Since you're using all the same color, you can put just a 2 here and just put a 2 right there. I'll know it. Believe me, I'll be able to figure it out. Now, do I expect this to be more than 50% or less than 50%? More, because it's more than half my graph, right? Because this helps me, because when I look up the area, it's the area to the left. If I look it up myself, I got to subtract it from 1. So I put this in. Did I expect this z-score to be positive or negative? Negative. Good, because I'm on the left-hand side. And I get a z-score of negative 0.96. And I expected it to be there. Now, when I look this up, I get this little answer. And I say, that can't be, because it's got to be greater. So, oh yeah, subtract it from 1. So I subtract it from 1. Your calculator, sometimes, depending on the rounding, this one didn't have to round any, it didn't have any other problems. So your calculator got the same thing. But your calculator gives you the final answer. Do not subtract it from 1.
On the test, would we lose points? Like, for example, I knew that you would just look up the opposite, so I looked at 0.96. Can I just write the answer?
Absolutely. Absolutely. You're using the symmetry part. That's perfect. It's just some kids still give me this answer. And that's what I want you to see your sketch there, because What Noah said is, could he look up the 0.96 and still give me the answer? Absolutely, that's symmetric. That's perfect.
So it's negative, you can just look up positive, you don't have to do it.
And you don't have to subtract from 1 because you're on the positive side and you're getting area to the left, which has to be that same area. Has to be the same exact area under the curve. And your calculator, if you use your calculator, it does it for you. Your last one, the in between, and make sure you set your inequality the right way. If you do this the wrong way, you're going to do 1 for this, 1 for this. And this is absolutely fine. And you're going to do it for this guy too. When do I subtract? At the end, you subtract your areas, not your z-scores, your areas. So you're going to find your z-scores for these guys. Find your z-score for this. And then you're going to subtract your areas. Because this one doesn't have a binomial. This is a regular. I can have my land cost be 7,400.5. I could have it 50 cents, not that I do, but this is not binomial. You're only correct with the binomial. So look at it this way. Yeah, oh, look at it this way. You're doing one thing different each time, which is why I laid this out. So either you are doing, correct, so bless you. Either you are doing this with your sample, or you're correcting it for continuity. You're only doing one or the other. If you have a divide by n, don't correct for continuity. That is not binomial. The binomial is when we have the u, the n, the p. That's when you have to correct for continuity. Okay, so you're going to go through this, and you're going to subtract your area. Now, this is a perfect one on your calculator. If for anything else, learn how to do this one on your calculator. What'd you get?
I got 0.9996 and 0.8729.
An 8729?
Oh wait.
Oh, wait, I read it wrong.
9251.
I got it.
Okay, now watch. Your lower limit is, what was the lower limit? 7,000? Your lower limit is 7,000. Your upper limit, oops. Your upper limit is 7,400, sorry. Okay, there's your mean, there's your standard deviation. Leave everything there. Paste. This will automatically find your areas. It will automatically subtract. So just round that to 4 decimal places. If you like to do the formula, get used to doing the in-between on the calculator. It's just so much easier. I know a lot of you struggle with where's my lower limit, -999, where's my upper limit, but this one has no one to worry about. It's got 2 x values. So just make sure that the less one goes in first. I don't know what would happen if you put it the other way. Let me see. If I change this, let's see. I'll just put this one 76. What would happen if I did this? I don't know if it'll give you an error. It's not possible. So this is way, way negative. You'd never get a negative area. So you would recognize this as something's wrong. So make sure that they go in the right way. That's the only difference. Okay. So that's 5.4. Do you have any questions on the ones that you did on 5.4 on the bottom? Any questions on those? Number 10 was a good one. Can you guys look at number 10 for a minute? Number 10 was a good one. This was number 10. You had to tell me, are you more likely to select one person with an IQ greater than 105? So where's that one person coming from? Your sample or your population? Population.
Where is this? What's the one thing?
The one that I handed back.
Oh.
It's not on the review sheet. The one I handed back. Or are you more likely to select one from a sample of 15? This is your sample. Now, some of you just gave me an explanation, oh, take the sample. It says you have to use your z-scores for this. So my population, my statement still says, what's the difference for this? One actually is your sample mean from your sample, and one actually is your population. When you do a population, that's just a straight z-score. When you do this, that's this guy, adjust this. They can't be the same. They got to be two different answers. So when you do this and you put this in, this was a common mistake, so I just wanted to point this out. The only difference here is changing the standard deviation. What's my sample size? 15. Okay, now, it has to be greater than. Don't automatically assume it's the one with the larger z-score, because where is your area for greater than? To the right. So if I found this area, I'd be 1 minus this guy. If I found this area, I'd be 1 minus this guy, who has a bigger area, bigger percentage. Bigger area, bigger probability, bigger percent. My population. Don't base it on your z-score. If it was less than, yeah, then it's the one with my greater z-score. But it was greater than. So don't fall into that trap. The rest, I think, we're okay on that. Okay. Just to finish this a little bit,
Are you gonna give us like?
I'll give you the formulas, yes.
Okay.
I wrote the formulas on the top of the page. Okay, now, this is how do I know that I just switched? Because I read this problem. A survey of U.S. adults found that 73% think the federal government should require genetically modified food to be labeled as such. You randomly select 12 adults and you ask them whether they think the federal government should require genetically modified. Determine if you can use a normal distribution to approximate a binomial distribution. So I've got a binomial situation. So what information am I given? I'm given a sample size, which is, and I need a mean, and I need a standard deviation. Am I given that? No, tragic. So what things give me N and P? I'm given the P and the Q. So what's my P?
0.73.
What's my Q? Okay.
That.
1 minus 0.73. Okay. It's a binomial. It has to add up to 1, so it could be a yay or a nay. Yes or no. Black
Can you
or
write
white.
out the quiz how to find Q?
Yeah.
Someone forget.
So now, all I want to know is, can I use this to model a normal distribution? So how do I define or decide, can I use this? Good. The n times p greater than 5, n times q greater than 5. And your test will flip to the next one because of this. Yeah, I'll do all the 5.4s together, and then I'll switch to 5.5. And you'll either see did you correct this thing for continuity, or did you test? And you'll know. So I test this. I say 12 times 0.73. Is this true? I say 12 times 0.27. So which one do I really, really, really have to look at? The 0.27. Because if the 0.27 doesn't pass, I don't care about the 7.3. It's not going to pass. So when I multiply this, I get 3.24. So what's my Final decision. It's not. Does not approximate a normal distribution.
So we can't do anything?
Nope, you cannot find the mean or the standard deviation. That's it. You're done. Well, no, because then you'd never have any work to do.
You're touching multiple choice.
This is college. If I handed Mercy College a sample of my test and they said multiple choice, I'd be fired. I'd be fired. I have to give them copies of my stuff. They have to approve that I'm teaching the right thing. Okay, you might see this. Correct this for continuity. I might give you a statement and have you write a probability statement and then correct it. So, how do I do this? This says greater than or equal to. I start like this. Where's my correction for continuity? Good. I only have two sides. If my left side is where it starts, drop that 0.5. If my right side is where it stops, raise that 0.5. Do I need the greater than, or do I need the equal sign? No, but I tend to keep whatever sign is there. You're never going to hit a 0.5 regardless, because it's a binomial, it's a integer situation. That's it. Correction for continuity. Because start like this. Here's my number line. What's the first number that I'm going to be able to do that makes this true? 25, and then what? 26, and it keeps on going up. If you subtract 0.5 from the lower.
The big thing is facing x is greater than, and if it's not, it's
Well, look, where's it pointing to? It's pointing to the right. What kind of numbers are to the right on your number line?
bigger.
Bigger, greater numbers. What numbers are to the left? Lower, less than. Add 0.5 to the upper if it's the other way around. So let's take this one. What numbers can I use for this? If x is less than or equal to 36. Well, okay, so what numbers can I use? 0, 1, 2, 3, 35, 36. Can I go any further? No. So this is my upper end. Add 0.5. That's your correction for continuity.
That's all you have to do.
That's it. How do I do? 65? Okay, hang on. Oh, so the x is equal to. So here I am. Here's my number line. I'm at the 45 right here. I need to measure this area. How can I measure the area of just a single point? So you have to make it a bar. So you have to make this a bar so it has some area. So you drop 0.5 and you raise 0.5. So now you've got an inequality that looks like that.
How do you know which way to put the?
It always goes to the less than.
Okay. This one.
Yeah.
Do you have to sketch stuff for these questions?
No.
I feel like that I know what's going.
Oh, for when you do the problem? Yeah, just basic sketch.
Okay. Like for 61, if it works, like you should draw the thing.
Well, you don't have any of your information, your mean or your standard deviation yet. But when you do, just give me a basic sketch. I just do that so that everybody realizes where their area is. Okay. So let's do one of these. A survey found that 52% of U.S. teens age 16 to 18. So 16 to 18 is an important part to know, but it doesn't affect me in my calculations. You randomly select 45 U.S. teens, and you ask them whether they have a savings account. They say yes, no. The 30 doesn't matter in this one, because it matters in the other one because we have to do the test for this one. We have to do this all the time. You have to do the test for this one.
Q is 1 minus 0.52.
Good. So P is 0.52, Q is 1 minus that, and what is N?
45.
45. So I certainly have some weird looking things here. This is my binomial. So the first thing I want to do is test my n times p. Is this true? My n times q, is this true? And both of them are true. Once you do that, this is your mean. That's your mean. So if you just put that one in, that's your mean. You have no other mean here. You have no mean, no standard deviation. So that tells you, use those formulas. Your standard deviation is n times p times q square root. Well, you did this part. Just multiply it by your q. And take the square root.
That for real good on our test.
You have to be able to do that. You have to find your square root of this, the whole thing. That gives you your standard deviation. So your standard deviation, make it to the same as this mean.
So
Okay, your sketch. Here's your mean. Even if you want to just estimate, if you want to estimate this to 23 and keep adding 3 up, I'm fine with that. You just need a ballpark. If you want to add 3.4 to this, 26.8, keep adding 3.4. If you want to subtract 3.4, just keep going all the way. I just need a step so that you use that. So now, let's hit this one. How do I write the probability statement for at most 15? That is the most I could have. Less than or equal to. Okay, now I have to correct this for continuity. So I can use all the way up to here. So how do I correct this for continuity? And that's it. The rest, I use my z-score formula for. 15.5 is over here somewhere, right? We just kind of estimated. Do you get less than 50% or greater than 50%? According to your graph. Less. So just make sure that you know where this is going. So 15.5, make sure you use the 15.5 over this. And figure out your z-score. Don't do the square root of n because you took care of that over there. Okay, so your answer is negative 2.32. You can look it up on your table. You'll get less than 50%. Did you plan on getting less than 50%? Absolutely. Can you do this on your calculator? Absolutely. Go to your normal CDF because we approximated your binomial one to be a normal distribution. My lower limit is way down here, negative 999. My upper limit is 15.5. Make sure you use the corrected one. And that's why I need to see what you put in. Because if you don't use the corrected one, you are never going to come close. Well, don't be that far off from the answer, but you won't get the answer. And neither I nor you will see it because it's done after you put it in. And paste. So it's a very small percent. You have about a 1% chance that this is going to happen. No, because your area to the left. That's why you do your sketch. Your table always looks up area to the left.
So that's one of it's negative, you just look up.
Yes, you just look it up. Even if it's positive, as long as it's area to the left. Okay, so what I did was I put this whole review on Edmodo for you tonight. So if you